I mean, here. Is it okay? No? Should I be on the page or
Okay.
is it okay?
Uh, wait, is that okay?
I'm not sure. So,
I believe it's okay. Yes. Please go ahead. I will ask behind. Okay.
okay. So should I start from first or I'm not sure. So, but anyway, also, okay, let me start from the first part. I'd like to start my talk from the beginning. And my name is Takayuki Nagai, and I'm from Osaka University. And today's my talk is about from intelligence to creativity. And first of all, I'd like to thank program chair, and for having me here. And it's my great pleasure to be here to present my recent work. All right. Can you guys hear me? Is it okay?
Yeah. You
Okay.
show your screen. Okay.
Okay.
I come back. Okay.
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 Sorry. Uh,
Okay.
can you see my screen?
Yes. I can say yes.
Okay. Okay. So this is the outline of this talk, and there are two parts actually. First part is about what is intelligence stuff. So this is a story about the project so far, and second part is like a kind of proposal. What should we do in the future? So about creativity. Finally, I'd like to summarize my talk. All right. So I need to be quick, but this is a kind of research direction, and this is about a quest, kind of a quest for what is human-like intelligence. So we are going to build a robot which has a human-like intelligence, and this is a kind of constructive approach. So this is the reason why I'm building the robot, intelligent robot, is to understand what is intelligence human beings. I think there are three parts. I mean, three important aspects. One is computational part, which is relating to the brain, learning computers, and the second part is body, robotics, control stuff, and third one is relationship. Right? It's about communication, so society, community, and so on. So these three must be integrated, and we need to study these together using the tools like robotics and AI, machine learning stuff. So it is a kind of broad question. That's what is intelligence. So I think I started this kind of work from 15 years ago almost, and at that time I think I should narrow down the problem, and then I need to have some kind of practical working hypothesis, and I decided to define what is understanding. So here's a nice theory of understanding. Is understanding is a kind of prediction on observed information through concepts, and meaning is that contents of that prediction, and the concept is a kind of generated through self-organizing process of multimodal information. So here's the illustration of the idea that, for instance, somebody said kind of stuffed toy. This is a kind of audio signal, and robot get this signal, and then robot try to map this onto the kind of multi-concept space. And robot
Sorry
find it.
sorry to interrupt, Professor Nagai. We are not seeing on the slides moving. We are in the outline slide yet.
Okay. Why is that?
Can you maybe try and put in the presentation mode to see whether, because we are seeing it as in your visualization. So that's maybe why it was not moving for us.
I can see the video. I can see, yes. I'm not sure.
So now I can see research direction.
Okay, so maybe, is it okay? Can you change, see the change of the slide? No? Or I
Have you
should, I
we
should
are
go on
still
this.
seeing research direction.
Okay, so I should
Maybe
use
you
this
can use
mode.
the full screen mode. Full screen mode.
Yeah, I did that, but nobody can see the.
Maybe you can share a different screen. Maybe you are not sharing your screen, but you're sharing just the application and it's sharing just the visualization through your visualization of PowerPoint. If you want, you can try to stop sharing and reshare. And when it asks what to share, maybe you can share the full screen.
Okay. Okay.
Thank you. Sorry for.
So no.
Sorry.
I'm so familiar with this tool, so sorry for that. How about this? Can you
Now
see?
we are seeing your, yes.
Yeah,
Now we are seeing perfectly the
Okay.
presentation. Thank you so much.
perfect. Thank you.
Okay. Thank you very much. I'm really sorry for that. But what I want to say that we have a kind of working hypothesis that's representing what is understanding and what we try to do to make the robot understand, I mean, predict the observable information. For instance, somebody says stop the toy, then robot try to predict the observable information like appearance of the object or hardness of the object and so on. So this is a simple illustration of the idea here. And I found that this kind of mechanism can be achieved by generative models. And I extend the probabilistic generative model to the multimodal one and then actually implemented this model on the robot and see what happened. But anyway, the important thing is that this probabilistic generative model actually have a latent variable d here. So this corresponds to the some kind of concept of multimodal concept here. So, and important point that we robot can actually predict unobservable information. For instance, if the robot gets observable information X here, and then other unobservable information can be predicted through this latent variable Z. So which is kind of met the requirements of this, working hypothesis. So that is how this model works. And this model is actually answers running models. So implement this robot on this robot, on the robot, and then test the robot during in the kind of interaction between human and robot, and see what's happening in this model. But this model is quite too simple to interpret our human intelligence. So we gradually extend this model towards more complex one. For instance, we actually connect this basic building block. And also robot needs to understand the kind of temporal information. So which means that something happened, then something happened, then something happened, and so on, using the kind of HMM, hidden Markov models. And also we want to make the robot understand the language. So language means that robot needs to understand some kind of grammar, like the order of words or part of speech. So we ask the HMM to make the robot learn the language. And also robot need to make decision. So we put reinforcement learning part here. So the important point here is that all of these modules are connected through the latent variable Z. So this is a kind of concept in the robot. And recently we can do this exactly the same thing with, of course, using the neural network. You can see that kind of the similar structure with variational autoencoder here. But we are using a kind of discrete representation. So we we need to add softmax here, but the idea is quite similar with the variational autoencoder. But anyway, what we can do is here the representation learning, and also reinforcement learning to make decision, and also temporal structure of this world using LSTM or recurrent neural network. But again, the important point here is that these modules are connected through the latent variables, which is we claim this is a concept. Right. More recently, we are trying to build the same model using the self-attention, which is say transformer, and we found that almost the same thing can be done with the self-attention, I mean, transformer. This is ongoing work, so I'm not saying about this much about this, but if you're interested in, please refer to these papers. Anyway, of course, machine learning community is paying attention this kind of world models also, and this is a first paper written by David Herr, presented in New Reps in 18. I think this is the first world models, and you can see the structure, quite simple structure here, but this is a representation learning part using variational autoencoder. And here is a temporal running part, and also here is a decision-making part. And it is also very interesting that to see that these different modules are connected through the latent variable Z. I mean, the concept inside this model. So the structure is a little bit different from ours, but the core concept are almost the same with this world model. So that is why we call our model world models. So anyway, I will show some results using the world models on robots. And we actually implemented this world model on real robots and form some kind of sensor motor loop here. And what we have done in 2016 is kind of experiment using 500 objects in the laboratory, and use this robot and try to teach some language using this robot and these 500 objects. And actually, my students interact this robot about over 100 hours. And so this is a video, but this is too fast because we show the video of 100 hours in 2 or 3 minutes. So this is 6,000 times to real time. So it's really fast to see. But the robot needs to actually, what the robot needs to do is to segment the speech, because there's no lexicon in advance. So robot needs to find out what is a word segment. So robot needs to do some kind of segmentation of the speech signal, and then robot needs to associate that words with the visual information and tactile information and so on. So I mean multimodal information. So that kind of interaction of modules actually emerge some kind of the object. Finally, we found that robot actually get almost 100 words. So this is a kind of experiment, and so this is a formal result, but we somehow try to compare with child development, but it's really hard to compare because the condition is not exactly the same. So this is not just a for reference, but we found that the speed of the running is almost the same with a human child. And also we analyzed the model and found some interesting things like the role of child-directed speech. And also we analyzed the kind of color concept and found that human concept and robot concept are quite similar. I mean, the developmental process of color concepts are quite similar with human and robots. All right, I need to be quick. So I also applied recently this kind of model to home service robots, but I think I should be quick, so I'll skip this part. But what I want to say is that we can use this kind of, world model to a domestic service robot, and robot can actually learn how to clean up the room and so on. It's actually possible. But of course, I think we do many things using real robot, but there are a lot of challenges in the future. So for instance, whole body skill learning is very important. Like I'm currently working on the humanoids to make robot learn the whole body skill like bars. And also communication is also important because the current model doesn't have explicit kind of communication modules. So we have to think about this, like self-other discrimination, mirror neural system, and so on. And also emotion is also very, very important part. And for, make the robot have kind of motivation. And also this is very much related to the reward stuff. And also higher level cognitive function is also important, like logical inference and understand kind of causality, and counterfactual simulation is also important. Explainability is also important, and creativity. I will talk about this later. That these higher level cognitive functions is very important to think about. And finally, I think consciousness. I'm not sure how we can solve this problem, but I believe that we can solve in the future by using the robot and machine learning technology. But anyway, talk about creativity next second half of this talk. So why creativity? That is the reason is that recent machine learning can generate a lot of interesting data, like facial images and music. Also, we can input lyrics, and then this jukebox actually generates the novel song. And drawing also, GPT-3 can generate a lot of sentences like human light. And Vocaloid can actually write a song for artists who already passed away. So this result reminds me of that question. The question arises that what is creativity actually? Or is it possible for a robot to have creativity? And this is another kind of example that, so this is just a simple result of reinforcement learning, but I can help asking that, why do you do that? I mean, this reinforcement learning result is just for the result of try to make the robot learn the bipedal walk, but robot suddenly walk like, crawling around and in all fours. So yeah, it's quite interesting. But this is just a result of reinforcement learning. So there's nothing to do with creativity. But I can help thinking about this robot has kind of creativity. So maybe this is a quite interesting insight that the creativity is not only in the generation side, but also observation side. So again, the question like what activity rise by watching this kind of video. Right. So of course there are a lot of research regarding creativity, and IBM recently launched the project like the Quest for AI Creativity. And New Rips has a workshop of machine learning for creativity and design, and they are discussed the generative models like GAN, GPT-3, variational autoencoder, and so on. And of course, there are a lot of research area regarding creativity. For instance, neuroscience on creativity actually reveals a lot of things on creativity, especially neural activation patterns during the creative activities. Like this is one of the papers, but BT actually revealed that 3 subnetworks involved creative thinking: default mode network, executive control network, and science network. So they claim that kind of synchronization between these systems is important for creativity. But I feel like this is very important and interesting results, but I think it's hard to understand what is creativity purely pursue this kind of neuroscience on creativity. So this is another thing so interesting that neuroaesthetics. This is a region for searching for the research on art, and this is an example of how to evaluate the artwork. And they also claim that action priming, when congruent with the artist's painting style, enhanced aesthetic preference. So it's very interesting that our motion as an observer actually influence our aesthetic preference. So in this research, they have an experiment that if you draw something using brush, then you tend to prefer the painting which is drawn by the brush. So this is very, very interesting. But even the aesthetic preference will be affected by visual motor priming. Of course, there is research on computational modeling on creativity, which is called computational creativity. And there are actually 3 papers. One is to construct a program or a computer capable of human level creativity. And second one is to better understand human creativity. And third one is to design programs that can enhance human creativity. So actually, there are 2 important factors in this. I mean, there are 2 important factors for creativity. One is novelty. The second one is value. So this is quite intuitive that if you are creative, then you have to create some kind of data or art works like which has novelty and also variable and value. So this is very, very important for thinking about the creativity. And research on computational creativity actually defines what is the creativity. I mean, what is creative data rather than creativity itself. But anyway, they define that creative data using K data set or knowledge and representation here and value. So the creative data is defined like K bar. And so this really is a kind of creative data. So the goal for creation or creativity is to generate the data within this region. But of course, if the machine learning methods represent only this region, it's impossible to generate the data around here. So the point here is that how we can extend this representation toward this region. That is a kind of problem here. So let's think about this direction. And if you can agree that the kind of creative process is equal to the problem solving or data generation, then the problem here is to find the novel and valuable data or solutions. That is a matter. So let me introduce one research research work by growing representations. This is quite a simple idea that we use again, actually. So that is a generative models. And the goal of a generative model is to represent the true data distribution, something like this. But as I said, if this representation is with only represent this true data distribution, it's impossible to generate outside of this true data distribution. So what we did is to extend or grow this generated distribution toward variable region. So one assumption we have here is that we can generate the data and we can evaluate its value. So that is a kind of cheating, but anyway, if we can evaluate the value for the generated data, then we can randomly sample the data from this generated distribution and then evaluate the value. And if the data has high value, then we add back to the data to the original data set and then train the network again, which makes the representation grow toward this variable region. So this is quite simple idea. And so this is an illustration how this algorithm works. But it's quite simple. That's generate the data, evaluate the data, and if it's high value, then add to the data set and train the model again, which makes the representation towards grow toward the higher variable region. So this is quite simple idea, but it actually works. And we tested 3 different tasks, like catching balls, scooping balls, hitting balls. And this model trained using a shape net. And this makes this model to generate a 3D, ordinal 3D object, but it doesn't work well for these tasks. And what we this model did is generate the data and actually try these 3 tasks and see the results. And the result is good, then the data is added to the training set and train this again and again. Then finally, the robot can get a good tool to achieve the high performance for these tasks. But this is quite, intuitive, and I think this is natural that robot can generate good tools for these tasks because robot knows what is value by testing these actual tools. And also maybe you feel like there must be a little bit different, like, this is just finding a solution for some tasks, and creativity is a little bit different from that kind of things. So what is that? Maybe the problem here is that we are always facing some kind of ill-posed problems. So maybe the solution is not matter, but what is important is how to use the kind of degrees of freedom. So in some cases, the degree of or constant itself can be changed. So that is a maybe important thing. And we sometimes think that the person is creative if the person can create or generate a new problem itself. So that is a matter here, I guess. So here is a good example for that. Here's a very famous composer named John Cage. He composed a musical piece called 4 minutes 33 seconds. That is basically sounds of silence, and the score instructs the performer not to play the instruct. So this is very, very interesting. And of course, there is a big argument that this is actually controversial. That somebody said that this is a value. This has a value. This is value of this piece is a new concept on, of course, that is silence. But somebody said that this is even not music because music refers to the sound produced by the composer or the sound produced by the performer, of course. So this is not even music. But here's the point that this is a kind of constraint that music refers to the sound produced by the performer. But he says that there is no difference between musical and non-musical tones. So the point of this musical piece, 4 minutes 33 seconds, is not in the silence, but the sounds that happened during this 4 minutes and 33 seconds. That is the sound from the audience. That is the sound from the performer, but not playing anything. So he claimed that difference between musical and non-musical tone. This is a very important point, and this is a kind of intention of the composer, John Cage. And this is a little bit different thing, but he is famous for the use of chance operation. So he tried to compose a music that is free from personal preference and traditions. So this is a very, very interesting example of what is creativity. And so the connection between creativity and kind of failure. So there are some quotes that one is called Adam said that creativity is allowing yourself to make mistakes. This kind of quote encourages us very much. And Joseph Pierce said that to live a creative life, we must lose our fear of being wrong. So I think these things like mistakes, failures, chance must lead to some kind of random in the solution space. And so there are a lot of ways to finding solutions, like growing representation, as I introduced earlier, and of course, random search, learning from failure, change of constraint itself, and so on. So let me summarize so far. I mean, this is a kind of recap so far. This is a simple diagram representing the idea of this creativity. The agent and his agent actually try to solve some kind of problem by whatever, I mean, growing representation, expand the representation toward variable stuff, variable region. And sometimes failure suddenly gives the solution for that problem, or random exploration is possible. And sometimes the agent can change the constraint itself, and constraint means that the solution space will be changed. So maybe the agent can go through this different space and find solution. And once find some kind of solution, then the agent can act in the environment and get evaluation from the environment. So this is a quite simple mechanism behind the creativity, but you might feel like, okay, so what is problem? Where is kind of does this kind of motivation come from? So one of the answer of this question is in the emotion, I think. So I think there is a big connection between creativity and emotions. So for instance, Nancy Anderson said, unfortunately, she's actually neuroscience scientist on creativity. And she said that unfortunately, creative thought is often inseparable from anguish. And there are a lot of research on relationship between emotions and creativity. For instance, negative feedback leads to creative work. And successful writers and artists have a higher prevalence of depression. So maybe this is a kind of general thing, but sadness enhances human concentration and zeal, allowing attention to more detail. But it's that we have a kind of moment of insight when we feel good. So we focus on something when we feel sad and get solution when we feel good. I'm not sure, but this is a kind of general founding. So this is very, very interesting. So let me add something like emotion here. So it's I said that emotion is information on our own body. It's deeply related with interoception. So we have, I mean, agent has physical body, and the information of physical body is a kind of emotion and give motivation to solve the problem. So meaning that emotion is important for keeping our body. I mean, kind of homeostasis or allostasis. So emotion will be the kind of motivation, some problem, and again, the problem will be solved by the certain methods or changing the constraint and so on. And then physical body can act in the environment to test the solution and get observation. So I don't have enough time to go details on the emotion. So please refer these papers on emotion stuff. I recently wrote a survey paper on robotic emotion in robotics. Please refer this paper if you are interested in. But still, I feel like, or maybe you feel like, but there's something missing. So what is that? So in order to know, I guess I'm sure that's something missing. So in order to know what is that, I want to ask the science of arts, what is art? So they're trying to, I mean, research in science of arts, try to find art, what is art? And Professor Yoko is really has an interesting thing that she said actually, art is communication. So this is very, very interesting thought. She said that art is a kind of activities that seek new materials and expression methods and aim for new communication with others through artwork. This is communication with others. So this is very, very interesting, and which is actually supported by intellectual curiosity that flexibly modifies the structured and organized knowledge and techniques acquired through experience using new discoveries and realization that emerge from one's own life and experience. So I'd like to say that this part, actually what I have been talking about, I mean, this part can be done by word models. So what I need to add is communication with others. So this is very interesting. I mean, creativity is very much related on the essence of the creativity is on the communication with others. And of course, there is a model relating to this kind of things by Csikszentmihalyi. He actually proposed the systems model of creativity. And he said that for creativity to occur, rules and practices must be transmitted from the domain to the individual. So from here to here. And the individual must then produce a novel variation in the content of the domain. The variation then must be selected by the field for inclusion in the domain. I mean, so the person can, for instance, generate something and then field judge it's novel or not, it's good or bad. And then if it's good, then generation will be the domain like culture or knowledge or something. And this domain will feed back to the person. And this also, he said that it is important to think about where is creativity rather than what is creativity. So he claims that the creativity is underlie this kind of whole system. So this is a very, very important insight from his systems model. Of course, this reminds me of this symbol emergence in robotics. I think big similarity between these two. I mean, here is a symbol system. This is a kind of, agreement among us, among community or, society. And that is correspond to this one, like culture or kind of domain. So maybe we can, understand what is creativity by in this, kind of whole system in symbol emergence in robotics. So we can have, so individual actually robot or human can have a kind of, world model and generate something and share the ideas and organize as a kind of symbol system or agreement, and then it must be a kind of constraint to run or generate new things. So this is a kind of system behind the creativity, I guess. So again, I have enough time to explain details, so please refer this paper for what is symbol emergence in robotics. All right, so now go back to the diagram. I'd like to add here the others as social. So the social actually, others can give the evaluation on the generation. Also, the agent need to explain what is that? I mean, about the generation. So create something, and then of course the creation will be provided to the society, but also at the same time, agent will explain what it is or why and how and so on. So this is a kind of communication process between agent and society, and so as we see in the example of John Cage, that the explanation is very, very important to make the generation or creation be a variable thing, social value, to make it socially valuable. So that is why I launched the new research project, which we called Explain Autonomous Robots. This is a kind of explanation generation by robots in order to explain by the robots to user what it is and why and that kind of things. But the essence of this problem is that communication between robot and human. So meaning that robot need to estimate of internal state of this part in order to generate a good explanation. So because robot need to explain which is unknown by this user or person. So meaning that robot need to understand that they understand of this person. And maybe this is a communication, so maybe user can ask again and explain again and so on. So this is a kind of communication between human and robot. This is a region more like human robot interaction. So of course, recently explainable AI, XAI, is really a hot topic, but XAI is looking at more focus on visualization of features that contribute to the prediction results. So of course, there are a big overlap between XAI and XAR proposal, but we are looking at more on side, so to explain what to explain based on the estimation of other internal states. So I'm really sorry that I don't have enough time to go in details on this, but I also wrote a survey paper on this, so please refer to this if you are interested in kind of explanation of autonomous robots. All right. Okay. I think that's it, and I'd like to summarize. This is the final version of my proposal of what is or where is creativity. And I'm not sure this explains everything, but this is a current version based on the discussion so far. And again, please remind that I wonder you can hear my voice or you can see my slide at the first part of my presentation. But my current research direction is based on the three important factors like computation and robotics, body, and relationship. And from these viewpoints, if you see this diagram, then you can find that this part is kind of computation, like machine learning, exploration by robots. And this part is about body, skill learning, or kind of, emotion based on the body. And this part is relationship or society. So again, these three parts are very, very important also for the creativity, for the kind of journey toward creativity. So I'm claiming here that current direction of thinking about the interview is maybe leads to the goal of what is creativity. And I believe that, strongly we believe that robots can have creativity in near future. All right, so I think to go through this, explanation, and it's hard to understand. I'm really sorry for that, and also I'm really sorry for that. I mean, the first part of this talk, but I think that creativity is actually possible. I mean, robot can have creativity in near future, and I think we need to work more on, communication or, machine learning and robot control, skill learning stuff. And thank you very much. This is a kind of acknowledgement. I would like to thank collaborators and labo members, foundation, and companies for their support. And this is final, truly final one. And I'd like to advertise the workshop, which will be held in 30th this month. And this is just the time, so please be careful with the time, but starting from 3 p.m. to 6:20 p.m. And this is a workshop about grant of next generation cognitive and developmental robotics, organized by Tadahiro, Shingo, Chie, and myself. So it's going to be very interesting because we are talking about next challenge and for cognitive and developmental robotics. And we actually invited young researchers to propose new and grand challenges for the future. So please join us to discuss this topic. I am sure that you can have a very, very fun for this workshop. All right, thank you very much. That's it from my side, and I appreciate your comments very much. Thank you very much. That's it.
Thank you, Takayuki. So I believe this is a very interesting talk. So anyone ask some questions or comments?
Thank you, Professor Nagai, for your presentation. I think you touched upon a very, very interesting set of topics. I was wondering if your models of robot creativity can envision also a component of human-robot co-creativity. You were pointing out that currently most creativity technology is meant to support human creativity. I was wondering whether in the future we can imagine of seeing instead really human-robot co-creation of creative works.
Right. I think that's the kind of the model I propose here is a kind of general model for creativity. And the point here is that creativity is a kind of not only the generation side, but also the society is also important. And society means the others. It means that, as I said, the creativity is the essence of creativity is kind of communication. So I think this kind of model can deal or interpret the kind of co-creation between human and robots. And my dream is that if the robot has kind of this kind of model inside, then robot can be a part of our society, meaning that we can live with robots harmoniously, meaning that we can, of course, co-create something with robot and human. So this is a kind of, very broad proposal, but that kind of collaboration will be must be included in this model, I believe. Thank you very much for your
Thank
comment.
you. Thank you very much.
Thank you. Thank you, Alexander, for the questions. So I got a question about the your first part, where you mean for the robot to learn the words. My
Okay.
question is uh, how you judge the robot learns those 100 words.
Okay. So as I said, I define some kind of definition of understanding. So that is, I'm not saying that is kind of true, or it is kind of ground truth, but my definition of understanding of words is that robot can somehow predict something different. I mean, the observable information from the words. Like, for instance, if the robot can uh, predict some kind of the bear-like shape from the words stuffed toy, then I decide, okay, this robot can understand the meaning of the words of stuffed toy, something like that. So actually, it's really hard time. I mean, I just judge one by one by checking what is the prediction by the robots for given the words. So I'm not sure this is you can agree with it, but anyway, right now we have a definition on understanding something like how much the robot can predict the ground truth. I mean this physical world. That is the meaning of the words right now.
Okay, thank you. That means the robot learns those words, their grounding meanings, not only just the symbols.
Yeah, right. That is correct. So I read your paper about direction concept, and that
Yeah,
was
thank you.
very interesting. And maybe we can share the same idea.
Yes, thank you. Okay, if there are any questions, oh, maybe we have no times. I believe. So, uh, thanks, Takayuki, for your wonderful, excellent talk. Thank you.
Thank you very much. Thank you very
Thank
much.
you. Okay, everyone, I think we will close the keynote speech. Maybe the next session will be start right now. Goodbye.
Keynote, the next session will be a poster teaser session, and it will start in about 15 minutes here in this conference hall. Just take this little break to get a coffee, maybe, and we will reconvene here in 15 minutes. Please, for the authors of the poster, of this poster session, if they can come in advance to the room and get in contact with the session chair, Anna Taniska, who I see here. Thank you very much. See you after the break.
Thank you, Alexandra. Yeah, yeah, yes, we really have a break. I did not find we have a break, maybe 50 minutes. Thank you.